Good morning, students. Today we are going to discuss the synthesis of nanomaterials. Before that, we had done the introduction part. What are nanomaterials? What is nanotechnology? What is nanoscience? Now we will continue with synthesis of nanomaterials. How nanomaterials are made. Okay, there are two different approaches: top-down approach and bottom-up approach. Firstly, we discuss top-down approach. Top-down technology was used in conventional nanotechnology. In this technique, nanomaterials are fabricated by manipulating large pieces of materials such as silicon crystal. In such technique, nanomaterials are produced by using process like lithography, etching, metallization, etc. In 1980, instruments such as AFM, atomic force microscope, and STM, scanning tunnel microscope, were discovered, which led to new technique of fabricating nanostructure, which is known as bottom up technique. In this technique, instead of making nanostructures from a large sample, we assemble atoms and molecules directly to form nanostructures or nanomaterials. This indeed allows us to think in both the directions, or we can see both the bottom up as well as top down approaches to synthesize nanomaterials. That is either to assemble atoms together or to break or dissociate bulk solid into finer pieces until they are constituted of only a few atoms. This domain is a pure example of interdisciplinary work encompassing physics, chemistry, engineering, and medicine. Right. So next is the flow chart of top down and bottom up approach. In this case, the bulk material is dissociated or crushed into fine particles in case of top down, and in case of bottom up approach, fine atoms or molecules assembled together to form nanoparticles, right? So these are two approaches: top down approach and bottom up approach, right? So now we will continue with the sol gel method, another method for synthesizing nanomaterials. Sol gel method is a wet chemical technique used for the preparation of nanomaterials, especially nanoceramic materials. Typically, precursors are metal alkoxides and metal salts like chlorides, nitrates, acetates that undergo various forms of hydrolysis and polycondensation reaction. The reactions involved in the sol-gel chemistry based on the hydrolysis and condensation of metal alkoxide RS4 so follows. MOR plus water give rise to MOH plus ROH, that is hydrolysis. And the second is MOR plus ROM give rise to MOM combination and ROH, that is a condensation, right? So following stages are involved in the sol-gel method. The first stage is the precursor means an acetate or a chloride that is dissolved in a suitable solvent to produce a colloidal suspension, that is called sol. And again here, precursor, solvent, water, catalyst, right? So that is dissolved in a particular solvent, we can say. So here sol is made. Then after, in second stage 2, a dehydration reaction of sol produces the required gel, right? So in the flow chart, you can see that there is a gel is formed in gel formation, second step, right? And third step is the gel is heated in a furnace at a suitable temperature to produce wet powder. So third step is production of wet powder, right? Or aging in mother liquor, we can say, right? So it is in a heated in a furnace to produce wet powder. Then powders are crushed with agate and mortar to form ultra fine particles. And fifth stage is the method is most suitable for oxides like zinc oxide, tin oxide, and alumina. It can also be used for making thin coatings on a substrate material, right? And this with the figure below describes how various steps involved in the sol gel method with the help of the flow chart. As you can see, precursor, solvent, water, catalyst leads to gel formation, which leads to aging and mother liquor. Then there is a washing, then it is heated, or we can say there's a drying process. In drying process, there's a zero gel due to evaporation, aerogel is formed. Aerogel, this is due to autoclave, and cryogel, this is a freeze and dry, right? Then after that there's a calcination process, and final material is obtained at last, right? So these flowchart is from these different stages. First, precursor is dissolved in a solvent to produce a suspension, colloidal suspension, that is called sol or solvent solution, we can say. Then dehydration reaction of the sol produces required gel. It is in the gel form, it's much thicker than that. Then gel is heated in a furnace to produce wet powders. Powders are crushed to form ultrafine particles. Then this method, we can say ultrafine particles are obtained, means we can say we had obtained the nanoparticles. The method is most suitable for oxides like zinc oxide, tin oxide, and alumina, right? And it is also used for making thin coatings on a substrate material. Advantages, what are the advantages of sol gel method? It is used to synthesize nanomaterials of very high purity. First advantage is that. Second, it helps in the control of microstructure by varying processing parameters, or by modifying processing parameters. The microstructure control can alter the physical and mechanical properties of the final powder, right? So method of production is economical. In case of sol gel method, large quantities of final product can be produced cheaply, we can say. Then moderate temperature are sufficient for drying and calcination. Then it is suitable to produce extremely homogeneous nanocomposites. Then one material can be coated on another due to sol gel process, right? These are some of the advantages of sol gel method. Another method for synthesis of nanomaterials is ball milling method. Ball milling method consists of balls and mill chamber. As you can see here, this is a we can say this is a retractory or steel balls, and this is a ball milling setup, or preferably inert atmosphere in the chamber is included. In this case, we can say first it consists of balls and a mill chamber. Ball mill contains a stainless steel container and many small balls made of iron, hardened steel, tungsten carbide, silicon carbide, which are allowed to rotate inside a mill, right? The powder of the material is taken inside the steel container and is covered into nano size. And it is converted into nano size using the ball milling technique. The ball mill is a process of producing ultra fine particles by a top down approach, we can say. So severe plastic deformation of the coarse grains can result in the desired product. A magnet is placed outside the container to provide the pulling force to the material, and this magnetic force increases the milling energy. When milling container or chamber rotates the metal balls, the ball to material mass ratio is normally maintained as 2:1. A silicon carbide balls provide very large amount of energy to the material powder. Silicon carbide balls, they provide very large amount of energy to the material powder, and the powder then get crushed. This process of ball milling is done approximately 4 to 6 days to get uniform fine powder. Ball milling is a mechanical process, and thus all the structural and chemical changes are produced by mechanical energy, right? Clear? So this is regarding ball milling method, ball milling setup. This is a diagram for ball milling setup. Then advantages of ball milling process are: first thing, nano powders of 2 to 20 nanometer size can be produced by using this technique, and size of nano powder depends on the speed of rotation of balls. And the second is it is an inexpensive and easy process, we can say. So disadvantage is that as the process is not so sophisticated, the shape of nanomaterial is irregular. Second, there may be contaminants inserted from ball and milling additives. There may be contaminants, right? This method produces crystal effects, we can say. Okay, thank you very much. These are the two methods. You can revise these two methods: ball milling method and sol gel method. Okay, thanks.